return, both in terms of reduced costs and benefits accruing from more successful projects. What we would be trying to achieve on behalf of a client like the World Bank, or any client with a lot of projects or a lot of work packages, is to train a machine learning model on their archive of projects, and which would then predict which projects are most likely to succeed and which to fail. We started with the World Bank because they have opened up their data on about 12,000 projects. From the last 50 years. Each project has been given a final class at the end of the project: highly satisfactory, satisfactory, unsatisfactory, etc. This is what we care about. We can train a model using supervised machine learning to predict this classification for projects that the model has not yet seen. The outcome was that for projects that the model has not seen, the model achieved a classification accuracy of 89%. The conclusion for our business is that this experiment shows a good level of success. We believe it's worth exploring further the applications of machine learning for advising companies with large portfolios. There are already many tools that can do this, and this is just one project use case of several which are already possible with the new methods. The methods are getting better every year, faster than our ability to exploit them, and I recommend we accelerate efforts to build a community of practice. So I'll now say something about how we did this. First, we extracted, transformed, and loaded the data. We brought the 12,000 projects in. We tidied up the data. As well as the final status of the project, each project has about 20 features, as you saw earlier, such as the date, the duration, the cost, and the results of different interim project reviews. This is the raw material that the model can use to understand what combinations of features are most predictive of eventual success. We then train the model. We apply the project data to several different machine learning algorithms. There are 4 here that prove to be the best, that learn to classify the projects into highly satisfactory, satisfactory, etc. We then compare the models. Here are the results, and chose the best performing model. In this case, the best performing model is the random forest. If you look here, you can see an alternative way of presenting the results, where the items on the line are the things that are correctly predicted. The items off the line are not correctly predicted, but is achieving 90% accuracy. What can then be done is to apply the model. Once you have selected a model, you can then apply it. Once trained, the above steps, these steps, do not need to be rerun. The model can instead be periodically applied by someone who has had a day or 2 of training. It will predict for an unseen project whether the project is likely to ultimately be satisfactory.